mistakes all the time. But anyways, I did the last one is there, so we're gonna verify this one. Then you can do it by yourself also another time. So we do now a graph. We select the data. On the X value, we put the last measurement. Yes, here the HH last. And on the Y value, we put the one that I just extracted. So now let us add a trend line and calculate the R squared. So actually you see R squared of 97%, which is not at all bad for those few points that we have. And this is why at the moment the physics prime satisfies me quite a lot. It gives nice results and it's quite satisfying. 97% is quite close. This means that the points that I've interpolated is 97% close to the measured point. Very close. So this small manipulation, you can do it whenever you do an interpolation, also to understand how close you are with the interpolation to the real measurement. At the end, every interpolation is an approximation in a way or another. Many, many different methods. How do you assess which one is the best? You can do this, which is a very simple method just to quickly assess how good you are and how close you are to the real value. And maybe to assess which one is the best of the methods to use. So that's what I wanted to show you regarding the creating contour lines. Now we are about 1 hour later from my schedule. Because next exercise that I wanted to see with you is how to create a topographic profile. So, because once you have your groundwater flow, an interesting part that you could do is to find the orthogonal line to the groundwater flow and create a line and then you will create a profile so that you can see really the groundwater flow under the topography, no? So if you allow me, I will show you how to do it, but you are not going to practice, okay?
Yeah, that's fine.
Because I want
to. Yeah, it's
you just look at how I do it so that you grasp a bit what are the steps and the points, but we are not going to do the practical work because it will take 1 hour more and I want to show you the last part.
And here we will have the recording, so we
Exactly.
later on take the recording, the record key, the Arabia for
Yeah.
for
And later on, if you are doing those things and you need some support online, also I'm available. No?
Yeah, some of the colleagues are here, they are capable to help other colleagues to do it. So we will keep these groups going on and we will finally practice all these steps. So please, you can go ahead.
Excellent. So anyways, just again to see a bit the procedure. In principle, you create this shapefile. It's very similar to what we've done now. You create this shapefile in QGIS. You create points along this line. You extract the SRTM value and the groundwater levels that comes from your interpolation to this file. And then when you have all these into a table, you will open it into the DBF file and you can then construct your profile. The important thing is actually to have your piezometric contours well done. So actually, I will go to the case of Kabul because I've done it already, so that then I which is I think one thing that you like. Okay, so in Kabul, you see that actually most likely here a good practice is to have two sets of data. That one set is the eastern and the western, and one set is the eastern aquifer, no? So for this, you will have to separate your set of data and then do exactly the same as you've done, create your contour lines and through the cubic spline. Now, you want to create a profile, which kind of starts from the mountains, goes within the flow of the water, and ends somewhere where, I mean, it's significant for you. So maybe we can take the western, this western aquifer. So first of all, I will create a line. To create a line, so you go in from the browser into the folder where you are storing all your data, right click, new shapefile, and here you have to define line stream. Line stream, and here we say profile Kabul West. Again, here you will have to create those points along the line. So better to have it in projected. I know maybe why it didn't work for you before, because also your system has to be in a projected system. If you were in QGIS and you did the cubic spline, but in projected, it possibly that's the reason why it didn't work. Yeah, your project also has to be defined as a projected project. Sorry, I thought suddenly why maybe it didn't work for them. Okay, so we created now this polygon, actually not a polygon, a line. Profile Kabul West, it is here, so I drag it into my my project and I start designing it. I think that I will actually put the geology on the top because it will tell me also where actually possibly this ends. So we said we want this one. I think I want, first of all, here the profile, that's good. So I want possibly somewhere, I want to start somewhere where, let's say I know that it's the limit of my aquifer. Now, but this is very far away, this point, very far away from where I have my data. I don't want to do such a big profile. So I think I'm gonna start somewhere here. You start here, you click once. Now you see that we are drawing a line. Click another time, and then right click. Right click will actually finish the polygon or the line that you've been editing. give it an ID, whatever, ID 1. So you have created now your line, and this will be the line where you want to withdraw your profile. So save it and toggle off the editing mode. Now, this is, I think, it has to be projected because now you want to create at a certain distance that you will be that I can do it with some tool, and I know kind of the key, but you do by doing your search, you will find it. No? So let us have a distance of 1000 meter, offset 0, and offset everything is fine. So I will now create these. No, I'm in Kabul now. Kabul profile, and this time, no, okay, I routed directly is profile Kabul West, and it will be points because it's the line that I created the points along. And run, and now we sample. So you see all these points have been created at a distance of 1000 meter. And now I will sample the SRTM on these points. So sample raster value. It's my points. I search for my SRTM.